Hello and welcome to physics. So in this introductory video, we're just going to talk about what physics is and what do physicists do. So first thing we're going to try to do, let's try to define physics. Okay, so if we're trying to define physics, things might come to mind like famous physicists, Albert Einstein, Stephen Hawking, Katherine Johnson. You also might think of the subjects you've studied in physics. Probably talked about forces and motion freshman year, electromagnetism. Okay, so these things are all a part of physics. But when we're trying to define what physics actually is, I think it's best defined by saying that physics is a tool. Okay, it's a tool that we can use to understand the universe. Okay, so when we're thinking about using physics as a tool, physics has allowed us to go to the moon. Okay, physics has allowed us to have phones, computers, these technological devices that can store so much information and be at our fingertips. But physics is also like what governs how our body moves. So it's a tool, and there's a wide range of applications for how we can use physics. One thing that I want to mention is at the core of physics, the language of physics is math. Okay, so you may or may not like to hear that, but math is fundamental to physics. In order to understand the physics, you have to have math as a tool. So math is the language of physics, and that means that the universe, since physics is a way to understand the universe can be described by math, which I think is just amazing. That's a really cool thing. So the goal of physics, okay, so we talked about kind of what physics is a tool to understand the universe, okay, and the goal of physics is to understand the world as it is now. So making observations about things that are going on now. And what happens with physics is a lot of times that allows us to make predictions about what will happen based on what we're observing now. And that's true with a lot of sciences as well. Or we can figure out what things were going on in the past based on observations that are taken now. Okay? So if you think back to, I think it was 2017, we were told that there was going to be a solar eclipse. I think it was towards the end of the summer. The exact date I'm not sure about. But physicists had a mathematical model, or they do have a mathematical model for how the sun, the earth, the moon, and our planets move, and were able to predict that we were going to have a solar eclipse, and predict where that was going to happen and at what time. So that is a prediction made by physics. So we're going to talk about something that you may initially not think is related to physics, but like a professional athlete who spends hours and hours and hours practicing their skill or their sport, they kind of get an intuitive sense of the physics as it relates to their sport. So a quarterback knows exactly where to aim and throw and with what velocity to throw the ball to hit a moving receiver. But any athlete, really, a lot of sports involve physics and can be analyzed with math and physics. But the athletes have a kind of intuitive sense of what's going on. And finally, another application of physics is like in engineering, building bridges, building buildings, building power plants. Engineers have to know about the physics of the materials that they're working with, and the physics of the strength, the loads, in order to put together a building, or in this case, the Golden Gate Bridge, put together a bridge that's going to withstand the test of time and be there for many years for people to enjoy and also use. So so physicists are able to make predictions. Physics is there's tons of applications of physics. Basically, physics is everything. Okay, so the second part of the video, we're going to talk about like how do we do physics, or how do physicists in the real world do their job? Well, they have to be curious. That's the first thing. Physicists are constantly asking questions like, why does that happen? How does that happen? They pick out things that they want to understand. And sometimes that comes from a previous study. Sometimes that comes from them reading some literature in their field. It could come from them just, taking a walk in the woods and wondering about something. So physicists are curious people, always asking questions. Physicists are developing models. They develop models, and a lot of times these are mathematical models of the phenomena they're interested in. So this can be also like a diagram or a detailed drawing about what's going on. And it can also be like a mathematical equation that describes a change in an object or a system over time. Okay, so physicists are often using models to test their ideas or their questions. And part of that process, planning and carrying out investigations. So I have a picture here of the satellite Juno, which is on a trip to Jupiter to kind of figure out about the origins and evolution of Jupiter. So these investigations can be drawn out over years and years and years in a collaborative effort between many physicists and engineers, and require years of planning, and then it takes years to actually get your data and collect it, and then years of data analysis. So most physics investigations are going to involve collecting some sort of data, and a lot of times that's quantitative data or numbers. You're dealing with numbers, and then you're analyzing your data using math. So the final thing we're going to talk about, physicists are communicators. So they communicate within their discipline, cross-discipline with other scientists, and also with the greater community. So that's kind of the last thing I have for you today. Thanks for watching, and I will see you in class.